Hello, welcome to today's class. In today's class, we will talk about Karnaugh Maps. It's the first class on Karnaugh Maps. So first, what is Karnaugh Maps? So Karnaugh Map is an alternative to the truth table uh, form for representing a function. So we already know what a truth table is. We can use a truth table to represent a Boolean function. And in a truth table, we list what would be the value, output value for each combination of the input values. So for each combination of the input values, we have a row, and for that corresponding combination of the input values, we specify what would be the value of the Boolean function in a separate column. Now Karnaugh Map is an alternative to the truth table. The Karnaugh Map consists of cells, and the cells correspond to the rows of the truth table. So for example, let us now look at the Karnaugh Map for when we have two variables. So here we have a truth table. Actually, we only have the input combinations. We are not representing a function exactly in this diagram. We are only listing the possible values for the two variables. Since we have two variables, we have four possible combination of the input values, and hence we have four rows in the truth table. And now we know that the first row, where x1 is 0 and x2 is 0, represents the min term m0. It represents the min term 0. The second row, where x1 is 0 and x2 is 1, represents the min term 1, and so on. And now when we want to build the Karnaugh map for these two variable functions, this is how the two variable Karnaugh map would look like. We have four cells here, and actually each of this cell will represent one of the row of the truth table. In the truth table we have four rows, so here in the Karnaugh map we have four cells. And the two variables x1 and x2, what we are doing is the columns will represent the variable x1. So when we write x1 here, it means the columns will represent the variable x1, and we are writing x2 here, and it means that x2 will represent the rows. So now for the first column, in the first column corresponds to when the variable x1 is equal to 0. So for the first column, the value of x1 will be equal to 0. So I write down those values. So in the first cell, x1 will be 0, and in this cell also x1 will be 0. Next, and the second column corresponds to the case where the value of x1 is equal to 1. So along this column, the value of x1 is 1. So I write those values. So in this cell, the value of x1 will be 1, and in this cell also the value of x1 will be 1. Now the rows represent the variable x2, and along this row, the first row, the value of x2 will be equal to 0. So when I write the values of x2, what we get is that in this first cell, the value of x1 is 0 and the value of x2 is 0. Whereas in this second cell, we already computed the value of x1. We said in this cell x1 is equal to 1, and now we see that x2 is 0. So in this cell, we have the input combination 1 0, where x1 is 1 and x2 is 0. In the next row, along the next row, x2 will be equal to 1, which means this particular cell represents the value 0 1, 0 for x1 and 1 for x2, and this cell represents the case where the value of x1 is 1 and the value of x2 is also 1. Now when we have 0 0, we know it represents minterm 0. So actually this cell represents minterm 0. 1 0 represents minterm 2. So this cell represents minterm 2. In this cell, the input combination values is equal to 0 1, and 0 1 represents minterm 1. So this cell is for minterm 1. And finally, in the last cell, both x1 and x2 are equal to 1, and hence it represents minterm 3. I would like to mention one thing here, is that instead of representing x1 along the columns, you may represent x1 along the row, and in that case you can represent x2 along the column. So we can switch these positions of the variables so that x1 may be represented along the rows and x2 will be represented along the columns. For the current scenario, where x1 is represented along the columns and x2 is represented along the rows, we have the minterm 0 here, minterm 1 here, minterm 2 here, minterm 3 here. So 0, 1, 2, 3. And if we alternate the positions so that x1 is along the row and x2 is along the column, then in that case our minterms will be 0, minterm 0, minterm 1, minterm 2, minterm 3. So you can use either of the method. So now minterms in any two cells that are adjacent, either along the row or along the column, can be combined together. So adjacent minterms can be combined together either along the row or along the column. So as an example, let us consider the minterm 2 and minterm 3. So minterm 2 is here, minterm 3 is here. They are adjacent to each other, and now m2 is represented by x1, x2 prime, and minterm 3 is represented by x1, x2. So now from the postulates and theorems of Boolean algebra, we know that m2 plus m3 will be equal to x1, x2 prime plus x1, x2. So we have just replaced m2 by this product term, the min term, and we have replaced m3 by the min term x1, x2. Now we can take x1 common here, so that we will have x2 prime plus x2 in the bracket, and from the postulates and theorems of Boolean algebra we know that x2 prime plus x2 should be equal to 1. So we end up with x1 dot 1 and finally x1. So as you can see, it is possible to combine adjacent min terms in the Karnaugh map, and we can combine to come up with a minimized expression. So our original expression is x1 x2 prime plus x1 x2. We can minimize it to be just equal to x1. So this is possible that we combine adjacent cells in the Karnaugh map. Now let us consider a truth table for a function f. So f is a function of the two variables x1, x2, and the function is defined as shown in the truth table. So the function f1 is 1 when x1 is 0, x2 is 0. The function f is equal to 1 when x1 is 0, x2 is 1, and f is 1 when x1 is 1, x2 is also 1. Otherwise f is equal to 0. Now we can represent this Boolean function in a Karnaugh map. If you remember, this was min term 0, this cell was min term 1, this was min term 2, and this was min term 3. So whatever is the value of the min term 1, I write it down in this first cell. Now the value of min term, so this was min term 0. Now min term 1 I have to write in this particular cell. So since min term 1 is equal to 1, and this cell will also be equal to 1. Next, min term 2 is equal to 0, hence this cell will also be equal to 0. And finally, min term 3 is equal to 1, so this cell represents min term 3, so this cell will also be equal to 1. So this is how we represent a given Boolean function in the Karnaugh map. Now we want to perform minimization of this function using the Karnaugh map, and to perform the minimization, we have to combine adjacent cells. So we make groups of adjacent cells, and we can make groups of size 1, or we can make groups of size 2, or we can make groups of size 4, or we can make groups of size 8, and so on. And how do we make groups? We combine the cells, adjacent cells, if they are equal to 1, and we consider the cells which are equal to 1 when we want a sum of product expression. So now in this example, I can combine these two adjacent cells. That's one group we can make. This is a group of size 2 cells. I cannot make a group of size 4 cells because one of the cell is equal to 0. I can group the cells only when the cell is equal to 1. In this case, this cell is equal to 0, so I cannot make a group of size 4. Nor can I make a group of size 3, because groups of size 3 are not allowed. We can have groups of size 1 or 2 or 4 or 8 and so on. So since we cannot make groups of size 4, next we check whether we can make groups of size 2, and yes, I can make this group of size 2. What about the other, this one that we have? This one again I can combine with its adjacent cell, which also is 1, and we can come up with a second group. So in this way I come up with two different groups, each of size 2 cell. Now once we make the groups, the next step is to construct a product term for each of the group. Now we have to create a product term for the first group, and we have to create a product term for the second group. So how to create the product term? I explain it. First we consider this group which is colored blue. This group consists of two cells. The two cells, one for minterm 1 and the other for minterm 3. The cell for minterm 1, minterm 1 is x1 prime. Remember, in this cell x1 is equal to 0 and x2 is equal to 1. So this cell was 0, 1. So 0, 1 means the minterm x1 prime, x2. And for the second cell, which is in this group of color blue, and for the second cell, this was your minterm 3, if you remember, and minterm 3 is x1, x2. So we have listed the product term or the minterm for each of the cell that is associated with the group. So this was a group of two cells, hence we have two minterms. Now in these two minterms, we will discard the variable which appears both in the complement and the uncomplemented form. So for example, in the first minterm, x1 is appearing in the uncomplemented form, whereas in the second minterm, x1 is appearing in the complemented form. So we can discard this variable x1, whereas x2 appears only in the uncomplemented form. So we should not discard x2. So after discarding the variable x1, we are left with x2, and hence the product term for this group of color blue, the product term for it is equal to x2. Now for the group colored red, it also consists of two cells. One cell is your minterm 1, where x1 is equal to 0 and x2 is equal to 1, and that represents your minterm x1 prime, x2. The other cell in this group is this one, which is minterm 0, and it corresponds to the minterm x1 prime, x2 prime. Now between these two minterms, if we compare these two minterms which belong to the group colored red, we see that x2 appears in the complement form and the uncomplemented form. So we can discard x2. However, x1 appears only in the complemented form. So we don't discard x1. We keep x1 variable, so it is appearing in the form x1 prime, and hence this group which is colored red can be represented using the product term x1 prime. So now we have obtained the product term for all the groups that are in our Karnaugh map, and now I can write the minimized Boolean expression using the two product term as f is equal to x1 prime plus x2. So this is the minimized Boolean expression for the given function. And how did we find the minimized Boolean expression? By using Karnaugh maps. If you try to apply the theorems and postulates of Boolean algebra on this function, you will be able to get this same minimized expression. However, using the postulates and theorems of Boolean algebra is it's not intuitive, whereas minimization using Karnaugh's map is a little bit easier. So with that, I would like to end today's class. We will meet in the next class where we will talk about 3 variable Karnaugh maps, and then we will also talk about 4 variable Karnaugh maps. Until then, goodbye.